All right, today we're going to look at this amazing synthesizer from Teenage Engineering. They have a series of these, so this is one of them that I really liked that has like a reggae style. It's part of the EP series that came out last year or the year before. So things I'm really excited about this. This is designed to be taken apart, and you can kind of see that with the logo right here. They actually call out what screwdriver goes in. So a lot of products are like anti-take it apart. This one's blatantly encouraging you to take it apart. So let's take a look. Other cool things, this is a microphone, CB radio style or walkie-talkie style click button. It's really plasticky and chunky in a fun way. It's got some cool buttons. There's integrated batteries, so this would be fun to rip apart and see what's inside. Other things I really like about this device, the LEGO aesthetic. So these little pins here are used to connect things like the battery door. On the side are holes that are standard issue LEGO Technic, so you can actually connect multiple devices together or stands or accessories with LEGO or whatever else you want. Even these caps here, I realized, are the right size for Legos, and if you pull it off, it's a LEGO Technic stud, so you could add a gear right on it and, you know, modify it. So very playful by design. I'm a huge LEGO fan, so this was really cool to find. Okay, so here's the product. Quick overview. We have a bunch of buttons here. Teenage Engineering says these are actually velocity sensitive, and I'll show you what I mean by that in a second. There's also a really cool LED segmented display with some light panels here. It's powered by either 4 AAA batteries or a USB-C port, and I think that's really creative. There's no internal rechargeable battery, but if you do happen to have a USB-C port on hand, you can plug that in. There's also some other cool things. So we have ports up here to connect to other instruments, headphones in, speakers out. The different colors are pretty rad. This is fascinating to me. This is a separate part, but it's the same color, and I have some theories on why, but we can dig into that later. Other things to call out, we have knobs, 3 knobs, love a good knob, a fader up here, which controls various things like filters and volume or whatever you want to assign it to, and then a bunch of other controls. These are notoriously complex to navigate and learn, but they're really fun ones to get the hang of it. So you can like set songs, sounds and things like that. I had my son record his voice onto here, which is really fun. But what I'll show you are the velocity sensitive keys. So let's go to, if I press down, it changes the kind of wobbliness of it. So I want to learn more about that. Okay, let's put this back on. Let's turn it off, and let's take it apart and see what we learn. Taking it apart, we just simply flip it over, and there are a handful of screws that are called out here. So these are PH0 Phillips head screws. Shout out to not using Torx screws. Again, very consumer friendly here. We're just going to remove all of them. Typically, you see these fasteners hidden underneath things like these rubber feet, but I like the way they just embrace them and put them in. There's also a nice laser-etched logo here, the peace sign and all the compliance information. And then things like the EP series, where it's designed and manufactured, is actually embossed in the text. So this is a nice way to have permanent information as well as things that may change, like your certifications, your model number, serial number, etc. So take out all the fasteners. And I'll immediately lose some of these, so let me put them off to the side in a pile. Great. 8 fasteners off. I have not done this yet, so I'm excited to see what we find underneath. I'm just dragging my finger around to see if there's any snap hooks or something that may be engaged. Typically that's the case. And I'll gently pry it off and see what we find. Let's first look at the bottom housing, and then we can put it off to the side. So immediately what I see are recessed features. My assumption, without looking at the other part, is that these are like the plungers from the buttons on the back side. They're through-hole components, and they have some stuff protruding down. So this is a way to cut out and make room, which allows you to kind of slam this down to the minimum thickness possible. They're really nicely filleted, which helps transition, so you don't really see any like flow marks or sink marks on the backside. This texture helps as well. This might be a location feature for this PCB. Here are these snaps that I just had to gently pry out of the way. And you can see the rectangular box around them. That's where the lifter is moving out of the way to form these undercuts in the snap hooks. And I'll get some detailed pictures here. Material is PC ABS. T11 probably means it is from a mold. It could be calling out which mold it's from, or the mold shot or revision. These are all kind of up to the vendor how they want to classify it. Other things we see, ejector pins all over the place. More lifters over here, a couple over here. Yeah, pretty standard issue. This is a thicker part than I imagined. I'd say this is like 5-6 millimeters. Let's take a look. Measure it with the calipers. Trying to get everything on camera too. 5 millimeters, look at that. So pretty beefy, adds some stiffness to it. Also allows you to get these like holes drilled in without visible marks on the backside. My assumption is this is for the batteries, these little channels here, and we'll see in a minute. Other cool things, these rubber feet press in like kind of grommets. So these are little rubber pieces that they just press into here. Okay, that's more time than anyone expected me to spend on the rear of a piece of plastic, but here we are. All right, let's take a look at the underside of the device now. This is awesome. We have a single circuit board, which is rare to see, that spans the entire width of the casing. These are the battery holders, so these kind of pop through, so they poked a hole in the circuit board. They're using some contacts built into the board to connect to the AAA batteries. Really rad little Teenage Engineering logo on here. Love that. So that's done on the silk screen, or in this case, it's actually exposed, I think, copper, which is even cooler. And then I see what I'm assuming are test positions, all these little dots. So typically during assembly, when you get to this stage, before you button everything up, you can put it on a fixture that has a bunch of little metal pins that connect to all these little pads. And they can do things like boot up the device, simulate running it, press buttons, things like that. It's a really nice way to validate your design before you keep going. I also see the EP-40 and a barcode, a QR code up here. So probably a part number internally and then some kind of QR code to track the batch of production. One thing I noticed with my unit, and you can actually see it now, I'll zoom in on it if I can, is this is bowing. And I wonder what's causing that. It looks like something got bent during assembly. So I'll take a picture of that before we move in. And then these little covers just kind of track in probably prior to the board. And that allows a little pop of color and call outs. And if you're making different versions of the synth, which they do, they can quickly pop in and out different colors and get cool CMF options. Really beefy perimeter here, around here. This whole thing is very stiff plastic. You can see these little openings for the connect. So these are probably made with sliders or lifters internally. Everything's really well done and feels super, super stiff. And then as I mentioned, these are the plungers for the buttons that protrude through in the backside. So these openings here allow this to sit as close as possible. So not only is this like reducing the size of the entire product, but it's also supporting these on the backside. Okay, we'll fast forward through all this, but I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, a shit ton of screws. My assumption is, they need this to feel rock solid. This whole thing feels incredibly stiff and solid for a plastic product. And I think it's all coming from these screws. So on a production line like this, my assumption is they have a auto feed screwdriver, which is connected to some like power source. And you just pick up a screw magnetically, put it in and zip it down. So this is going to be a pain in the butt for me to take apart, but it's not that bad on a production line that's designed for this. One other thing that I wanted to call out, I believe this is manufactured in Spain, which is awesome. I haven't really seen a lot of products made in Spain yet. And this is a very, complex consumer electronics product. So that's very, very cool. These screws are the same. Also, shout out to them for not making me keep them separate and track them. So I'm just going to blast through this. I have not removed this yet, but I do notice a bunch of vias and traces on this really cool white masked circuit board. It's a little hard to show, but when the light catches it, you can see things are getting pretty busy around here. My assumption is that the bottom half of the board is very dumb and very boring on purpose. Now, if we flip this over, you can see it's mostly buttons and faders and knobs. So I'm expecting most of the brains are going to happen right around here. And that's because our USB-C port's here, so that we have to do some power management. We have our switch, we have our connection. So all the smarts, my assumption is, will be up here, LED control stuff, which kind of reflects in the traces and vias we see over here. I am not an electrical engineer. Anyone who is would tell you what's actually happening. But let's flip it over and see if I'm right, and we'll go from here. Other things I'm assuming, these little plastic covers are probably going to come up with the board and fall on the ground, and that's fine. I'm just getting ready for it. There could be some tape being used as well to hold everything together, but with all these screws, my assumption is no. Okay, I heard a pop in a good way, and I think we're off. Yep, okay, it's just extra support structures. So let's set the board to the side and look at the plastic parts first because I'm a mechanical engineer. These knobs popped off, and so that's what was holding everything together. I should have removed the knobs first. Lesson learned for any time I do this again. Set my knobs to the side. As I expected, these plastic covers kind of fell out of place. We'll put them to the side to review later, but they're pretty cool the way they track in here and stay in position. Again, I think this is for a nice pop of color, but also for CMF variations in the future. Inside here, we have a few things that are pretty interesting. First off is this white rubber shroud, and this is allowing or preventing light bleed between LEDs. So each LED sits in those holes and they light up each one of these little icons. And in order to have them crisp and light up only the icon that you want and not its neighbors, there's a shroud. And so these are little holes that help prevent the light from bleeding between each other. This is a tiny little circuit board. My assumption is that this connects to the main board with like little metal pins. And the circuit board is a breakout for the speaker. Oh yeah, there's the rubber boot for the microphone. This is a very cool part. It does a lot of things at once. It's like an isolation feature for the display, shock absorbing. It's also pressing down on the speaker and the microphone. So this is really, really nice. Let's peel it up. You can kind of see how these work. These like cone shapes help insulate or isolate the light. And it's a nice flexible rubber part. Really, really cool. You can start seeing through this translucent filter. So I guess the LEDs are all the same color is my guess. And then this mask has the color built in. So you get these really nice vivid appearances of each LED. What else can we look at? There's that board. These are battery connectors that are press fit into little features. So my guess is this is the custom part they designed, stamped metal, popped in place, and then probably, again, metal pogo pins or connectors there. And then this power switch, I did not expect to be, I guess, I didn't know what I expected, but it has a little snap metal piece that gives it one direction or the other. A really nice tactile feel. And then there's some grease in there, some white grease, just to provide some lubrication. I am not sure how this turns into the power turning on and off on the board, so that'll be fun to play with and take a look. Other things to note, these little colored rings are snapped into position. And then it looks like the display is held in with this translucent green polycarb or acrylic molded part. Okay, let's get super nerdy and talk about this top housing. So it's very hard to see in the video, but there's ever so slightly a draft or an angle off this face. So this is not perpendicular to the top surface. It's probably canted out by about, I don't know, 2 to 3 degrees. So the reason for that has to do with how you design parts for injection molding so that they can eject from the mold without creating essentially a piston holding it in place. So proper part design, you add a couple degrees of draft depending on how much texture you want. However, that's not the case if you're using sliders. Sliders are part of the mold that come in and out off angle. And I know they're using them for a few reasons. One, these holes on the side can't be manufactured any other way aside from a slider or a pick-out. And a pick-out is time-consuming and expensive. So my assumption is this mold has a slider that's probably the entire width of this that pulls out like this before the part gets ejected. Another reason I think it's done that way is this little ring here would mean that I can't, well, first off, I can't get it in here anyway. So yeah, it has to be pulled off this way. Sorry for nerding out too much. The other thing I noted is on the other side, they embossed the 4 AA battery logo in here. And again, the only way to really do that is with the slider. Same with the hook features that are used to capture this. So yeah, there's a slider being used here. And I don't know why they didn't just go with a perpendicular wall here, aside from maybe maintaining uniform wall thickness inside. But again, I would have just put 0 degree draft on this, hit them all with sliders, hit the bottom with the slider, which I don't think they needed, and hit the top with it too. So these two are unnecessary. These two are already happening. Curious to see why they didn't do it. Another cool thing I saw, see this little cutout right there? That's to prevent sink marks. So they have these really thick walls that add a lot of rigidity. But if these two pieces of plastic met in the middle, they'd make a really thick section and could actually sink or pull the plastic inwards and prevent this really sharp corner from forming well, or adding like a little wart or a visible detent here. So instead, they actually cut away the plastic right before it meets there. I haven't seen that before. I also haven't seen very thick parts like this used often. Again, I think this is around 5 millimeters of plastic. It's very beefy, very hefty, and it allows you to do things that you typically can't do with 1.7 millimeters or 2 millimeters of plastic, like these thicker screw bosses. These would cause, again, visible sink marks on the top surface. My assumption here is Teenage Engineering said it's got to be made of a single piece of plastic, reduce costs. We're okay increasing our costs slightly by going with thicker plastic because it allows us to add this complexity inside. All right, we already saw the back. Let's flip it over. Moment of truth. This is where all the magic happens. So let's take these little plastic covers off. Now, I was a little confused about the shape of these, but now I understand that these are actually providing a little bit of support for these ports. So if you plug into this port, you can risk damaging this. This is surface mount solder, which means that there's no like really strong connection between the part and the board. If I push really hard, I could probably snap this right off, which is not great. So one cool thing is this plastic part allows for cool color material finish options, allows you to add these lifters and sliders on smaller pieces, which is cheaper, but it's also providing support. So it's doing a lot of things at once. Here's a bunch of ports. They're all the same. 1, 2, 3, 4, 5, 6. USB-C jack. Here's our power switch, which, okay, I'm starting to get. It's just a little trigger boy. So it's like a momentary switch that gets pressed by the motion on the rocker over here. Bunch of components which are over my head, but we can ask people smarter than me. Battery connectors, so these 4 plated sections touch off on the battery connectors that are press fit in here. This, I believe, is for the speaker connector. It's the same thing. It's these 2 pads that make connection with the circuit board. And then we have our segmented display and a metric shit ton of LEDs all across this surface. These are tiny little guys. So these are not red, green, blue. These are all one color. My assumption is white. What else do we got? Down here, an encoder. So these are rotary encoders or knobs. They are not pressed down. They're just twist. And they have this cool Lego shaft. So there's 1, 2, 3 of those. And then a mix of hard plastic and rubber components that make up this shroud. So this black part is a soft rubber, and it kind of just like nests over and snaps into position. And inside are these little white light pipes, which are used to help transmit the light from an LED through a hole in the casing here. You can see them next to some of them. And then the buttons like tempo are actually separate parts that have little feet on them, which adds spring force, I think. And then edit, commit, loop are actually rubber, and like they're just logos. Same with output and system, but these are buttons. So there's a really interesting blend of hard plastic and rubber parts together here. And they do a really cool thing with like CMF options, texture options, where the play and record buttons are shiny, but the rest of them are matte. Okay, I gently pried off some of the hard plastic buttons, and you can see we have 2 things underneath. One are very standard issue tack switches. These are just SMT buttons. You can hear them. They're very clicky. And they are just put right on top of they're soldered onto the board. And this little plastic guy here, when you press down on it, you're pressing on this button. This has a really fun built-in spring arm and stopper feature that I'll investigate later. But it kind of pokes into the rubber and hooks underneath, and yeah, it feels really nice. They did a good job here. The button caps are held in with these nice plus shapes, and so they're just press fit on top of the button. And these look like essentially keyboard keycap switches. I see TTC on it or something, so I'm going to dig into the manufacturer later. My guess is these are semi-custom. Teenage Engineering worked with a vendor to make them. So I'll gently pry all these off. Okay, we're here. Let's pull it off. I'm going to start in a corner and just gently pry up. Don't want to damage anything. Yep, this is super cool. This is a compression molded rubber part. What looks like it has 2 different colors in it. I've never personally made a part like this, but I'm very jealous of those who have. some other cool things is that actually the light pipes are kind of over molded in there, I think. So they're hard. Are they hard plastic? They're rubber. So this mold is doing a lot of things at once. It's doing white and green and text molded in. It's doing this clear part, and it's doing a black shroud. I am ignorant about compression molded plastic parts or rubber parts, but I am very eager to learn more. So I may have to do some research here. Setting this aside, this is super rad too. So here's all our buttons, boop, 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 right? These are all the same. These are the keycaps, and it looks like, I don't know how they're attached. It looks like they're soldered, so I'm not going to do anything stupid here. But it looks like they're actually gently resting. So like this half is fixed and this half floats. So when you push down, you're actually pressing and deforming this button ever so slightly against the circuit board, which is fastened down in a million positions. So these little traces that go left and right, I believe are force sensitive resistors. So these are built into the board. And by pressing down on the button, you're actually changing ever so slightly the length of this squiggle, which is detected by the unit as compression force. And that's turned into like how much pressure I'm applying to the button. Okay, I'm gonna try something potentially stupid. It's gonna use many hands, so we'll see how I pull this off. But I'd like to plug in the USB port and power this back on. So the lights are on now, which is cool. My assumption was that this is when it's pressed down, it's off. When it's up, it's on, which is interesting. So that's probably for testing purposes like this. But now you can kind of see what's going on with the light shrouds. They're doing a really good job of isolating these LEDs and lighting up very clear squares where they need to be. So this is a really awesome way of getting this like pixel effect. Other things to note, you can see the LEDs working for the light pipes here. So let's just press play. Let's choose a song that I actually have music on, which is hard to do without the buttons, but I think it was this and this. And obviously there's no speaker attached, so we won't be able to see what's going on. But these LEDs are blasting away, which is perfect. If I press the FX button and try different things, you can see how they start lighting up, and the animations here are just really cool. I think the high pass filter is pressure sensitive. Yeah, so if I hold it, one thing, but if I press down, you can see the display starting to change based on how much I'm pushing down. So that's that force sensitive resistor at use. Same here. This is me again. I forgot to record a little bit of this. I took the screen apart later and wanted to share what I found. So let's get into it. First, we can see the PCB. This has a grid of white LEDs. These LEDs correlate to the icons that you see on the synthesizer. In the center, you can see the 3-digit 7-segment display. On top of this, we add our rubber part. This rubber part is white and glossy. It helps scatter the light. It helps form the light into these nice little squares and rectangles. Next, we added a diffuser sheet on top. This sheet helps spread that light evenly across the entire width of what I'm calling like a pixel here. So instead of a hot spot in the center, it helps make it more uniform. And then you can see these very clear divider lines in between each pixel. On top of this, we have a printed display. Now this is a piece of translucent plastic. It's white on the front with these translucent logos, and then the back is masked with black to help prevent light bleed in between. Each one of these logos is printed in a different color, and it is translucent, meaning light can shine through. This is how we achieve the logo and the color of each of these items. Finally, we have our clear or translucent plastic cover that goes on. I believe this is polycarbonate. One thing to note is you can also see these little dots, and these dots go all the way through these sheets. These are very thin sheets that line up, and these pins or dots help align everything in place. So this whole stack up from board up to here is how you get these really bright and vibrant colors and effects. And one of the very cool parts about all this is when Teenage Engineering wants to make a new product, all they have to change is this sheet right here, right? So the rest of this internally is the same. It's just a new piece of printed plastic they place in, and all of your icons, all your colors are different. They also change the color of this plastic overlay, which is just a CMF for color material finish treatment. So it's a very cool way to add this flexibility again on their synthesizer and preserve that core circuit board. Just really. So as a mechanical design engineer, obviously I'm most jazzed about the plastic parts. What I think is really elegant about this design is they have a very colorful synthesizer that's really fun to play with, and you want to approach it based on all the like cool colors and textures and the way they did that is really elegant. So we have our bottom cover, that's a single part. Pops of color are added with rubber feet, very straightforward. These are all the same part from the mold. So we're looking at 2 parts so far. Set that aside. I'm afraid to take this apart. So we're gonna call this one plastic part here, plus a screen display cover, and then a insert of like some piece of lamination to do the LED masking. So 1, 2, plus a post-process. This is pad printed. So pad printing allows you to add texture, allows you to add text and logos on here. So this is a molded plastic part, pad printed in a few locations, flipped over, and they install the speaker, circuit board, battery terminals. Again, the same part used over and over. The switch and the display. So I'm calling this like the top housing sub-assembly. 1, 2, 3 discrete plastic parts here. 1, 2, 3. So now we're at 4, 5 custom components. This is our 6th, a crazy compression molded part that I really love. Set that aside, that's 6. 7, this is our battery cover. Again, textured, and then they add a pad print for the logo. This also allows you to make variations really quickly, so that's 7. 8, our light shroud, mic cover, speaker gasket, compression molded. 9, our 4-port cover. This is a separate molded part, add support, all the jacks, different color, different pad printing. I forget the number I think we're at 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I believe that's 18 parts. I'll do my math again. What's really cool about it is, by separating these parts out, you can now have a green cap on your knob. You can now have an orange button. You can now have a variation of the keycaps. So you're just using the same part, but modifying the post-processing, the color and the pad printing to get this variety here.